Close that one. All right, so first one would be just a greatest common factor. Can you think of a number that you can divide out of 5, 10, and 30? Good, put 5. What else can you take? And can you shut the Chromebook on? X, good. So 5x is your greatest common factor. Now you're going to divide everything by 5x. And if you're able to do that in your head, you don't have to actually write this 3 times, but it helps to be able to see it. And it only takes a second. I'm just saying I won't mark it wrong if you don't write that is all. And then you're going to divide them. Here the 5s cancel. What are you left with? Yeah. X, 1x to the 3rd. You can put the 1 if you want. Did that spill or are we? All right, good. Minus 2x to the 6. And then plus 30 divided by 5 is 6. The x is canceled out. So that's your answer for the first one. Those of you that got a chance to start this, did that go? Yeah. Okay. Like maybe a slight problem, but we got through. Lovely. I'm super proud of you. Now, when you look at the second one, you have to be a good noticer. Do you see how many terms this is? 4. That means you're going to do grouping. So you do half at a time. Right. So just look at the first half. From both of those, you can take an x squared. So we're going to divide an x squared from both of those. We're just doing half the problem at a time. So what is left after you divide out an x squared? We're going to put what's left. Good job. 2x plus 3. Spoiler alert. The second half of the problem is going to have. So when I cover this up, what can you divide out of both of those? Now, specifically a -7. Good. Now, when you divide by -7, you'll be left with 2x plus 3. At that point, you kind of don't even really need to do that part mentally. Like you can check that it comes out the same, but it will come out the same. And then your final answer, you're going to have these 2 sets of parentheses. Like that's how most factoring ends up. In one of them, you're going to have that thing that they have in common, the 2x plus 3. And then usually I just cover it up. What's going to be in the other one? Beautiful.
Does it matter?
It does not matter what order you put them in. Okay. Now, this one is a trinomial. You have an x squared, an x, and a number. Do you see anything in front of the x squared? No, so it's one of those basic, easy ones. We're going to do an x box. The -77 goes up top. The 4 goes on the bottom. Now, I don't worry about the negatives first. I just come up with numbers first, then deal with the negatives. You need numbers that multiply to be 77. It would be 11 and 7. Then worry about the negatives. The negative would go with the 7 because 11 minus 7 is 4. So these are the 2 numbers we got. And in your 2 sets of parentheses, you're going to have x plus 11 and x minus 7. If you don't have anything in front of the x squared, it's just basic and easy. Like those numbers are your answer. Word. Yeah, you have to put the variable back in. So you have to put the x back in. All right, flip over. Do you see how this is a 7, a 21, and a 14? You have to be a good, divide by 7. You have to be a good noticer. We're going to divide them all by 7 and take out a greatest common factor of 7. That's right. So when you divide by 7, you're left with x squared. Beautiful. This is going to go nice and smooth because you guys are paying attention. Now, this worked well last time. Do you remember how I just covered up the number out front? Yeah. Then we did the rest of it, and then I brought it back. Okay, you're going to draw your X box. What number goes up top? 2. Good. And then on the bottom, -3. So you need numbers that multiply together to equal 2. You really don't have a whole lot of choices there. Good and good. They're both negative. Again, I usually get the values first and then secondarily I'll worry about the negatives, but they will both be negative. Now, this is just a basic, easy one. Draw your 2 sets of parentheses, and then those are the numbers that you're going to use. So x minus 1, x minus 2. And then, yes, I'm gonna move my finger back off of that, and we need the 7 back in there. Now these last two, oh, question, go ahead. It does not matter. So if you wrote this instead, completely same answer. Let me address that in a minute. So look at these last two. Do you see how they both have a number in front of the x squared that you can't take out? Yes. Like, why can't I divide all this by 8 the same way I divided all these by 7? 8 won't go into the other ones. So this is a tougher problem. I might need to pull up the calculator for this. The number up top, it's not going to be the negative 15. You have to multiply these together. So hold on, let me grab my, oh gosh, I have too many things open here. So let me share my screen so it shows up on the recording. You would have to do negative 15 times 8. So did you say negative 120? Yeah. Oh, good job. Negative 120. So negative 120 goes on the top. Negative 14 goes on the bottom. Now, again, I'm going to share my screen and use the calculator. I'm going to type in 120 over x. I don't worry about the negatives until the end. Like, we'll just deal with that when we come to it. Now you're looking for a pair that'll add or subtract to be 14. Let me hit enter a bunch of times. Do you see any that'll add or subtract to be 14? Oh, good. 6 and 20. Do you see that there? 6 and 20. All right, so put 6 and 20. Now let's worry about the negative. To get a negative 14, yeah, negative on the bigger one, so negative 20. Now, you can't just use those numbers. Do you remember what we put them over? Because we made fractions out of them. Good, over 8. Good, nicely remembered. You guys have good memories. You're going to take both of them, 6 over 8, negative 20 over 8, and then reduce the fractions. If you have trouble reducing the fractions, the calculator will do that for you as well. Look at, I have to delete all this back again. Hold on a second. What was the first one? 6 over 8? 6 over 8, turn it back into a fraction, 3/4. Yeah. And then what was the other one? Negative 20 over 8 would be negative 5 over 2. See, the calculator will do it for you. Did you get that? Yeah. What was this one? 3/4? Draw your 2 parentheses for your answer. Good. Oh my gosh, I love you guys. You're awesome. Denominator first. So this one will be 4x plus 3. And then the last one would be 2x minus 5. Can I show you a trick? Now this will work on the SOL if it's multiple choice. Okay, which the majority of the SOL is multiple choice, but sometimes they give you those drag and drop things. This won't work for that, but let me show you a trick, okay? You can type the original problem, which, what was it, 8x squared? Watch, because this is gonna really be helpful to you. Minus 14x minus 15. Do you see the graph here? It's this like U shape. Now I'm gonna type the answer we got, 4x plus 3, parenthesis, 2x minus 5. Do you see how it landed right exactly on top of each other? Like it's the same thing. If it's multiple choice, you can type the problem, type all the choices, and pick the one that lands exactly on it. Look, what if we messed up the symbols? What if we did a minus 3 and then a plus 5? Do you see how they're not exactly on top of each other? And then you can know that you have done goofed, okay? Isn't that cool? All right, let's try this last one. Draw your X box. We need a number to go on the top. It won't be the negative 2. It'll be negative 2 times 18. 6. Good. You guys are good with those times tables. And then 9 goes on the bottom. So I need numbers that multiply to be 36. 4 times 9 comes to mind, but that's not going to add up to be 9. So 12 and 3. And what needs to be negative? 3. Because 12 minus 3 equals 9. Now you're going to take those numbers and put them over 18. Now, for the sake of time, and again, you could put these in the calculator and turn them back into fractions, but this one will be 2/3, and this one will be negative 1/6. And then for your answer, you're going to draw your 2 sets of parentheses. Start with the denominator. So this one would give us what? 3x plus 2, 6x minus 1.